All right, so now let's talk about the domain. So we've already talked about two issues to look for when we're asked about domain of a function, right? So one of the rules is we can't divide by 0. The other is we can't take the square root of a negative. So we're now about to talk about another issue. When we have log, let's go back and take a look at a log's graph. So most of them, they pretty much look like this. What do we notice about the domain? Well, we're never going to have negative numbers inside of our log, and also we never have a 0. So we can't have x equals 0, we can't have x be negative. Alright, so you can test this out with your calculator too. So if you look at your calculator and take log of 0, domain error. 0 is not in the domain of a log function. Or maybe you could do log of -3. We can't take the negative, a log of a negative. And the same with natural log. All right, and so one thing I forgot to mention before is the natural log is also on our calculator. It's this ln, and the calculator gives us a hint. The base is e, and there it is. E is right above it in green. All right, so your calculator can tell you the base of these two logs. All right, so let's go back to this problem. Let's find the domain of our function. So remember, whenever we're talking about domains, we need to figure out, okay, are there any issues with this problem? Are there any issues with any x values we can plug in here? Well, we can't plug a 0, and we can't plug a negative into a log. So we cannot plug in 0 or a negative in a log function. All right, so what does that mean? That means all of the stuff inside the log function can't be 0, and it also can't be negative. So 9 minus 6x can't be a 0 or negative. So what can it be? That all that's left is positive. So can we set up some type of inequality to help us find all of the x values that will make the inside of this log positive? All right, so we can do 9 minus 6x greater than 0. That makes it positive. Okay. All right, I'm going to add the 6x to both sides and then divide by 6. So we can write it like this: 9 over 6 is greater than x, or it may be a little easier to see x is less than 9 over 6. So all of our x values must be less than 9 over 6, which is 3/2. Okay, so to write our domain in interval notation, all right, we want everything less than 3/2, so we want to go from negative infinity to 3/2, and let's think about it. Do we want a bracket or a parentheses? Parentheses, because we don't want to include 3/2, because if we do, we're going to get a 0 in here. So you can test that out to make sure. All right, so let's talk about evaluating logarithmic expressions. All right, so we want to find the answer to this. And so it may be easier to think about this in equation form. So it says you may want to rewrite this in exponential form to either solve or to check your answer. So the first one, we want to figure out log base 2 of 1 over 8. We want to figure out, okay, what number is that? This is not something we can plug in the calculator because we don't have log base 2 in our calculator. Well, we can figure it out algebraically. Let's say this is the x we want to find. Log base 2 of 1 over 8 equals x. All right, so how could we solve for x? Well, first, let's put it in exponential form. We know how to do that. right? So our base is 2, exponent is x, and we equal 1 over 8. So we have 2 to the x equals 1 over 8. It would be really nice if we could rewrite 1 over 8 as 2 raised to a power, because then we know exactly what that power is going to be. We can rewrite 8 as 2 to the third, so I'm going to do that first. So 1 over 8 is the same thing as 2 to the third. So we've probably seen this before in class, but whenever you have something with a power in the denominator, we can move it to the numerator by changing the sign. So this 2 to the x is going to be, this is going to be the same as 2 to the negative 3. All right, so what does that tell us? Well, x must be negative 3. All right, so is that true? Well, let's see. What if we raise, so here x is negative 3, let's check it. 2 raised to the negative 3, that's 1 over 8. That's exactly the answer we were looking for. All right, let's do another one. This time we want to figure out log base 3 of 27. So I'm going to set that equal to x, and that's what we're solving for. So our first step, okay, we don't really know how to think in logs, so let's switch into exponential form. All right, so my base is 3, my exponent is x, and this should equal 27. All right, so the goal that we want is, we have 3 to the x over here. We really want to be able to write 27 as 3 raised to some power. So can you rewrite 27 as 3 raised to a number? What about to the third? And we can always check this with our calculators. 3 to the third is 27. All right, so x must be 3 here. So we just discovered that log base 3 of 27 equals 3. All right, let's do another one. Log base 4 of 0. We're trying to find what that is, so I'm just going to call it x. Red flag should be going off in your head. Log of 0? We've already discovered we can't take a log of 0, right? The domain of a log is from 0 to infinity, not including 0. We should not be able to do this. So let's see why it doesn't work. Well, let's rewrite it in exponential form. So 4 to the x equals 0. All right, so can you think of any numbers that you can raise 4 to and get 0? Well, 4 to the 0 is 1. 4 to the 1 is 4. Actually, this can never happen. This is never true. So that tells us our answer is undefined. You'll never have log base 4 of 0. All right, last one. Let's do log base b of 1 over b to the third. So solving again, exponential form, our base is b, okay. Exponent is x, and so that should equal 1 over b to the third. Again, we do have b as our base, but it's in the denominator. This one isn't in the denominator, so we can move it by making the exponent negative. So that tells us our exponent, our x, is actually negative 3.